So b to the 5 halves equals 243. How is this different from yesterday's problem?
Variable is the base.
Right. Yesterday, all the problems we solved, the variable was in the exponent. But now I have the variable in the base. Now yesterday, when the variable was in the exponent, we had the two bases, so we were able to get those bases identical to start, and then after we had our common base, we could drop it. But if I don't even know the base, am I going to be able to just get a common base here? No. So we have to have another approach. Give me your thoughts. What could we do?
We can rewrite it as b to the square root of b to the fifth.
Okay. So b to the 5 halves, that is the same as the square root of b to the 5th. Now, is that a problem we could solve? Yeah. How would I do that? You guys are so chatty today. This is fun. Okay, square both sides. If you want to cancel a square root, you can square. So I get b to the 5th equals 243 squared, 59,049. Okay, how do you get rid of a 5th power? 5th root. If you add a 5th root, do you need a plus or minus? No, only if you add an even root. So those cancel and I get b. The 5th root of 59,049 is 9. So we got a nice answer. Okay, I want to walk through a couple other ways we could have done the same problem. We could have, at the beginning, we wrote it as the square root of b with the 5th under the square root, but can't you also put the 5th outside the square root? And if we had done that, if the 5th were outside the square root, then the first thing you would do would be to add the 5th root to each side, because then the 5th root and this 5th power cancel, so we have the square root of b equals, what is the 5th power of 243? Sorry, 5th root. That's 3. Then just get rid of my square root, now we square, and we once again get b equals 9. This way, it looks a little more awkward to write at the beginning because you have those two radicals, but we have smaller numbers to deal with along the way. Another option, and I want to caution you on this option. I'm going to show you why in a minute. But I sometimes have people that just want to look at the original and say, well, if I took this to the 2/5 power, 5 halves times 2/5 is 1. And I get b equals, what is 243 to the 2/5 power? 9. Now, this way is dangerous. I'm going to show you why on the next example. It gets you there, but not without a cost. You have to think about it a little bit more. So it seems faster initially, but you have to think more at the end. Let's talk about this second problem. If I just worked it this way, so h to the 4/3, what power would you have to take it to? The 3/4. So if you do that, you would get h equals, what is 81 to the 3/4? Okay. Now, let's work it one of the other ways. If I wrote this with a radical first, how would I write that? H to the 4th. Okay. Alright, if I want to cancel a cube root, what do we need to do? Cube each side. So 81 cubed, 531,441. How do you get rid of a fourth power? Fourth root. But what do you need to put with that? Plus and minus. So I get h equals plus or minus. What is the fourth root of 53,000 or 531,440? Okay. So I got two different answers. This is the correct answer. Plus and minus 27. If you do the first method, you notice it worked on part A, but on part B I only got half my answer. Do you know why? Yeah. You have to look at the power you're raising it to. If your denominator is odd, you're not going to have to worry about it. But if your denominator is even, then you need to remember to put that plus and minus out in front. So because I raised it to the 3/4 power, 4 was an even number, that meant this had to get a plus or minus. Now that might be hard to remember for you. So if you think you might forget that, don't do it this way, do it with the radicals, so that you don't have to worry about forgetting your plus and minus along the way. Questions there? I'm going to put a few up for you guys to do. Let's say z to the 7 has power equals 128. First one, this means the square root of z to the 7 equals 128. Did you square or do the 7th root first?
I squared first.
Okay. 4. Now we need a 7th root. Does this one need a plus or minus? No. So you could have also at the very beginning taken this to the 2/7 power, and that would have gotten you your answer. And you get 4. Okay. On D, how'd you guys do that one? Okay. So you wrote it as the cube root of y to the 4th. Cube each side. Okay, so then 16 to the 3rd gives you 4,096. To get rid of the 4th, you need the 4th root. With that, you have to have plus and minus. So the 4th root of this is 8. So plus and minus 8. If you just originally did 16 to the 3/4 power, that's okay, but what you have to remember is if you take it to that 3/4, since the denominator is even, you have to add in the plus and minus yourself. Okay. So E, do you want me to do it with radicals or by just taking it to a power? Taking it to a power? Let's try that. I haven't done one that way yet. So this one you'd have to take it to the 2/5 if you want to do it that using that option. Do you have to add a plus or minus? No, because that denominator, the 5, is odd. So what do you get? 4 again. And you could have also wrote this as the square root of a to the 5th. Solved it that way. So we have lots of options on these. All right, F. This one's uglier. Some uglier numbers, and I threw a negative exponent and a fraction in here. What'd you do first? Lots of options for how to begin. Okay. Did you rewrite it without a negative exponent or just try to get rid of your exponent? Okay, so you just multiplied to a power? Is that what you're saying? Okay, that's fine. So if you want to get rid of that, you could just take it to the negative 3/8 power. Now, what do you have to watch on this? Because that denominator is even, we do have to add in a plus or minus if you do that. So you take that to the 3/8 power, you get, sorry, negative 3/8 power. Plus or minus 27. Did anyone like me to work that one out a different way? If you wanted to write it, with the radicals at the beginning, you would just need to get rid of the negative by making it 1 over that. And then you could cross multiply and get rid of your fractions altogether and solve it like the others. Okay, so are we good on this type of problem? The last main type I want to cover today is an inequality. So your homework is going to have some exponential inequalities on it, and we solve these the same way as our exponential equations. So in other words, we are getting a common base to begin here. If I'm looking at this one, what would my common base be?
3.
Okay. So 3 to the 2x is less than a1 is 3 to the 4th. Same base on each side, so you can drop it. The inequality just is like your equal sign. It's just going to trail along. The only thing you have to remember, just like any other time you're dealing with inequalities, if you multiply or divide by a negative, it flips that inequality. Otherwise, it stays the same. So then I would divide by 2, and I get x is less than 2. Now, I expect your answer to be written in interval notation. So less than 2, how would I write that as an interval? With a parenthesis, because there's no equal to. And that's all for A. So just like yesterday's really, except it is an inequality, so at the end you do have to write an interval for your answer. Let's take a look at the next one. So on this one, what would you use for your common base? We can take it to a 2 if we wanted, or we could deal with the 1/2, can't we? Let's deal with the 1/2. I just want to practice that and make sure we're okay with it. Because I know you guys like to get rid of the fractions, so I'm going to make you suffer with them for a minute. So 1/16 would be like 1/2 to what power? The 4th. And you still have your x plus 3 out there. Okay? So then, what do we have to do with these exponents? Power through power, you multiply. Okay, so then you get 2x is less than or equal to 4x plus 12. Subtract your 4x. Divide by a -2. What does that do to my inequality? I get x is greater than or equal to -6. What would that look like as an interval? Bracket -6, comma infinity. Okay. I want to talk about something on this one real quick. What if we had taken it to a base of 2 to begin? So 1/2, if you wrote that as 2 to the -1, 1/16 would be 2 to the so we get 2 to the -2x is less than or equal to 2 to the -4x minus 12. If you drop your base, add our 4x, divide by 2. How would I write that answer? That one's -infinity to -6. So I used 2 different bases and I got 2 different answers. Which one's right? The first one? Can we check? Give me a number bigger than -6. Let's go with a nice number, like 0. Okay, plug 0 in in the original. 1/2 to the 2 times 0, so 1/2 to the 0 power is 1. Okay, this would be 1/16 to the 3rd, or 1/4096. Is that true? Okay. Give me a number smaller than -6. Let's try it. -7. Okay, if you put a -7 in. So you get 1/2 to the -14. These are gonna be some nice numbers. Less than or equal to -7 plus 3 would be -4. And that one is true. story here. I told you it was just like dealing with the equations, but when your bases are fractions, it gets a little dicey. Okay, there's a little more thought involved in it because of when you flip the negative exponents, it kind of impacts your inequalities a bit. So, if I gave you one of those on your homework, how could you know if you had the right answer or not? Do exactly what we did. We picked a number and plugged it in and saw if it worked or not. Now, which one did work for us when we changed it to a base of 2? So this did not work out, but the other one did. Okay, so what I just want you to be aware of. Now, when your bases are whole numbers, it's not really that big of a deal. If you pick a number between negative infinity and 2 and plug that in like a 0, 3 to 0 is 1 less than 81? Yeah, that was no problem. When you have the fractions as your bases, without adding a lot of extra work to your problem, let's just say this. Let's try to go to the whole number base and then check your answer at the end and make sure you have the correct interval. Okay, without adding a lot of other tricks to you, I think that is the easiest way to go about it and make sure you're correct. Yes, ma'am.
If it's not that one, is it gonna be like the exact opposite?
Yes. Other questions? Do we need another one of those? Alright. You guys, homework, I am going to post a handout in Classroom. I think I forgot to post that this morning, so I'll do that right now. And you have